Hello all. So myself Professor Kishan from Department of Mechanical Engineering, MIT, Mysore. So in today's session with respect to the subject fluid power system for the 7th semester Mechanical Engineering under VTU curriculum in module 1, in continuation with the previous session, I'll be dealing with the first topic, that is transmission of power at static and dynamic states, and the next topic is Pascal's law. So before understanding the concept of transmission of power, let us try to understand the concept called as static and dynamic. What do this static and dynamic mean? So it is a general sense that we regularly use these type of words, but in relation to what we have to study with respect to the power transmission, so I have taken just a brief definition for the static and dynamic. So what is static? Static is concerned with the bodies at rest or the forces in equilibrium. Whereas in case of dynamic, it is relating to the forces that produce motion. So here, when it comes to hydraulics, so based on the different components what we have studied in the previous session, that is the layout of an hydraulic system. So what happens is, we'll be having the fluid, that is the working medium, transferring through various components in the working cycle. So each and every working cycle will be consisting of the same working fluid that is moving from one component to another component, and meanwhile we are supposed to target the transmission of this particular working fluid from one particular point to the another particular point in the entire components or the circuit of hydraulic system. So when it comes to the transmission of power in case of fluid power system, we are going to concentrate on two things. One is the hydrostatic transmission, another one is the hydrodynamic transmission. So what is this hydrostatic transmission? So hydrostatic transmission is a transmission that deals with the mechanics of still fluid. So means to say that if we take hydraulic system, it is one particular fluid or a common fluid which is being recirculated for n number of working fluids. We are not going to take a fresh working medium or a fresh fluid source for every cycle. We are reusing the same fluid over a period of time. So at this particular point of time, whatever the mechanics we are going to study with the same fluid which is present in the entire system, that we are going to consider it as hydrostatic transmission. So here in this hydrostatic transmission, we are going to get the pump which is the heart of a hydraulic system. So the type of pump which is being used is positive displacement type. What is this positive displacement type? See, there are two types of pumps basically. One is positive displacement, another one is non-positive displacement. So what do this positive displacement type of pump do is that it accumulates, a restricted amount of fluid in it and then sends that particular fluid with a particular pressure. Okay, whereas in case of non-positive displacement type of pumps, so here the fluid will not be collected or it will not be restricted. Instead, the continuous fluid flow will be considered for the transmission of power. So the example for hydrostatic transmission, as I already stated, so it is the transfer of fluids in the hydraulic system becomes one major example for hydrostatic type. Similarly, when it comes to hydrodynamics, so it is a transmission type wherein it deals with the mechanics of moving fluid. So moving fluid is nothing but a continuous fluid source which can be taken into account. So one of the simplest example for hydrodynamics type of power transmission in fluids is that, so the water turbines. So the water from a reservoir will be fed through the penstock and then it will be fed onto the turbine, so that the turbine rotates and generates mechanical energy, and that will be converted into power generation in the later stages. So here the fluid which is being considerably fed to the water turbine, which is continuous, means to say that for every rotations we are not going to feed the same fluid. Instead, what we are doing is we are going to take the fresh fluid altogether to run the water turbine. So that is one mode of power transmission which is considered under hydrodynamic state. So this is something on transmission of power at static and dynamic states in fluid power system. Next, moving on with the core part of hydraulic system, that is Pascal's law. What do we know? Before defining Pascal's law, let us try to understand what does this Pascal's law reveal. This Pascal's law reveals the ability at which the hydraulic system can work. Okay, so in this particular Pascal's law, we have few key terms. One is confined fluid, another one is undiminished, and one of the major parameters is called as perpendicular. So these are the three key terms which are considered in the definition of Pascal's law. So what do we mean by confined fluid? So confined fluid is that which is restricted with its area or volume. The fluid, if you take one simple example here, just like a container here, so whatever the fluid we fill into that particular container, so that will be fixed. The area or volume is fixed. Moving on with the term undiminished. Undiminished is nothing but without any losses or without any reduction. So these are the two terms wherein we have to remember once we are dealing with the concept called as Pascal's law. Let us move on with the definition of Pascal's law. So here again one additional note is that in case of the definition of fluid power system itself, we have used the word called as pressurized fluids, because whatever fluid we use here in the hydraulic system or the fluid power system, it should be accompanied with certain pressure so that that pressure results in the accountability of external work done as per the requirement. So the word pressurized fluids will be generalized using Pascal's law here, and the Pascal's law is been defined like the pressure applied to a confined fluid is transmitted undiminished in all the directions throughout the fluid and acts perpendicular to the surfaces in contact with the fluid. Means to say that whatever pressure we are going to apply on the confined fluid, means to say that the fluid which is restricted by its volume or the area in which it is being accountable for is transmitted undiminished. Means to say that whatever pressure we apply on the confined fluid, without any losses, the same pressure will be transferred onto the fluid. Okay, in all the directions throughout the fluid. Means to say that throughout the fluid the pressure will be constant and acts perpendicular to the surfaces in contact with the fluid. This perpendicularity and the surface depends on the structure in which fluid which is being considered under the application of pressure. So the simple illustration is taken here. We have considered the illustration of a bottle which is filled with the fluid. The fluid is basically now confined, and we have a stopper at the top of bottle lid. So here, to illustrate the Pascal's law, the pressure which is being applied onto the stopper, that particular pressure is transmitted undiminished. Means to say that throughout the fluid the pressure will be same. And how is that particular pressure is being accounted? It is perpendicular to the surfaces in which the fluid is coming in contact with. So you can just refer this particular profile here. So this is the vertical profile of the bottle wherein the pressure applied is perpendicular, and similarly throughout the surface, if you can just refer these arrow marks, that represents the perpendicularity of the application of pressure undiminished throughout the fluid. So ultimately, to state, according to the Pascal's law, the pressure which is applied on a confined fluid throughout its fluid, throughout the volume, that remains constant. Now, with respect to the definition of Pascal's law, we'll just take an example of a hydraulic jack. So this is the constructional feature of hydraulic jack here, which describes the effectiveness or application of Pascal's law. So here we'll be having two pistons, piston 1 and piston 2, having the cross-sectional area A1 and A2 respectively. So here this is a hydraulic jack which consists of incompressible fluid, that is oil. So the force is going to be applied on the piston 1, and the extension of piston 2 results in the work which is to be extracted. So here, if I can just explain the features, explain the constituents of the hydraulic jack here. See, the inward force is taken as F1, which is being made to fall on the piston 1, which is consisting the area A1. So the movement of piston in the linear direction, that too particularly in the downward direction, is said to be S1. Similarly, according to the Pascal's law, once the force or the pressure is being applied onto the stopper, as in that particular explanation, here in case of piston, the pressure will be acting on the piston, and that particular pressure is said to be P1, since it is considered for acting on the piston 1. Similarly, on the outward end, we have a piston 2 having the cross-sectional area of A2 here, and the outward force, which is a resultant of the force which is being fed on the piston 1, that is being considerably taken into account to transfer the load onto piston 2 such that S2, the upward movement of piston, is being identified, and that resultant force will be considered as F2 here. Okay, so according to the Pascal's law, if we can just state that the pressure should be constant, so the pressure which is being applied onto the piston 2 end as well as the piston 1 end should be constant. So that we have taken here based on Pascal's law, P1 is equal to P2. So if we just substitute the equation for the values for P1 and P2, that is substitution force per area, F1 by A1 is equal to F2 by A2. So just to bring it for a particular link, we have taken it as F1 by F2 is equal to A1 by A2. So here what happens, the volume of the oil which is considered in the hydraulic jack is constant since the oil is incompressible. So that therein what so due to that, so the volume remains constant, that is V1 is equal to V2 if we consider the volume which is present at the piston 1 end remains same as that of volume which is considered at the piston 2 end. So the volume is same. So here with respect to the definition, volume is area into height here. So area is the cross-sectional area of piston, what we are going to take on piston 1 as A1, piston 2 as A2 here. And the height is nothing but the displacement of piston 1 and piston 2 here, that is S1, that is downward movement of piston 1, and S2, the upward movement of piston 2 here. If we take that particular consideration, then V1 will be equal to A1 into S1, similarly V2 will be equal to A2 into S2. And using the equation 3 concept here, that is volume remains constant, so what happens is A1 into S1 will be equal to A2 into S2. Upon simplification, we are going to end up with a result which gives us the relationship between force, area and the displacement, that is F1 by F2 is equal to A1 by A2 is equal to S2 by S1. So this is the illustration of the Pascal's law using a hydraulic jack. In this particular session, we shall study on two topics. One is the fluids for hydraulic system, and next one is the properties of hydraulic system. Under fluids for hydraulic system, we are going to study different types of fluids that can be considered for the hydraulics application. The first one being water, next being petroleum oil, water glycols, and the last one is synthetic oils. See, each and every type of fluids do possess their advantages and disadvantages. So if we study on water, we know water is abundantly available in nature. So along with its economical factor as well as its availability, there are few other parameters which the water cannot be considered as a sustainable fluid medium in a hydraulic system. The major thing is the corrosion, then lubrication to the moving parts. So these are the few parameters wherein water cannot satisfy, and since in hydraulic system it is continuously number of elements will be moving all together to perform a particular action, so selection of water will not be suitable for hydraulic system. That too basically hydrostatic state of fluid power transmission. Moving on with petroleum oil, the disadvantages of water will be overcome wherein the petroleum oils do possess good amount of lubrication to the moving elements in the hydraulic system, but the major problem is that its flammability. So the petroleum oils do have the ability of catching the fire if the pressure is reaching a very high range than the defined. Moving on with the next one, to avoid this, to overcome the disadvantage of petroleum oil when it is being considered as the working fluid in hydraulic system, that is its flammability, we have a non-flammable fluid called as water glycols, which is a combination of water 50% and glycol 50%. This combination of 50-50% may be varied based on the output or the application wherein it is targeted. And the last one being synthetic oils, which are the oils which are derived or synthesized using certain chemicals called as phosphate esters. So the major advantage of the petroleum oil, water glycols and the synthetic oil is that these three fluid types, which if we consider in hydraulic system, they provide enough amount of lubrication for the moving components in the hydraulic system. And along with that, these three oils will definitely avoid the rust formation, definitely avoid the foaming. What do you mean by foaming? Foaming is nothing but accumulation of small air bubbles in the fluid. So this is something regarding different types of fluids for hydraulic system. Next, when we select or when we opt for any of these kinds of fluids, we do have certain selection parameters here to be considered. The first parameter being transmission of power. So the fluid, whatever we use based on the application, that should transmit the power constantly over a period of time wherein the extraction of work is being defined. And the next parameter which should satisfy is the lubrication of the moving parts. And the third one is the dissipation of heat. Since the same fluid will be recirculated in the hydraulic system, there is a chance that the heat or the pressure in which the fluid is being transmitted in the system results in the generation of heat. So that heat should be dissipated so that the properties of fluid will not get affected. So that is one among the selection parameter wherein we are going to select when we take with all these four types of hydraulic fluids. And the last one is being the economical factor. Just because we are going with certain advanced applications or very high performance applications, the economical factors cannot be skipped here when we are selecting the different types of hydraulic fluid. So basically what happens is synthetic oils are preferred over very high performance vehicles or very high performance applications. So at that particular point of time, the economical factor should also be taken into account, because a machine will not be designed to perform one operation at a time, wherein the machine or hydraulic system or in specific fluid power system will be defined for continuously providing the same output over a period of time. So these are the four particular selection parameters should be satisfied by the different types of fluids based on the application the hydraulic system or fluid power system is being defined. Moving on with the specific properties wherein which we are supposed to concentrate on the hydraulic fluids are the first one being viscosity, viscosity index, demulcibility, oxidation stability, lubricity and rust prevention. So to define viscosity, it is the resistance of flow by the fluid at definite temperature. So we all know that the constant fluid is being considered to run or to move throughout the hydraulic system. So if the resistance being offered by that particular fluid is more or less, both will result in improper functioning of that particular application. So to define with the viscosity, the fluid which is considered in the selection parameter should possess correct viscosity, because if the viscosity is too low or if the viscosity is too high, there will be a definite impact on the moving materials, moving components in the hydraulic system, which even reduces the life of moving components. Moving on with viscosity index, it is defined as the arbitrary measure of fluid's resistance to viscosity change in temperature. Means to say that since the same fluid is being recirculated over a period of time, there is a chance of increase in the temperature of fluid. So at that increase in the temperature, when the temperature of fluid is increased during the operation, the viscosity index should be high. That means to say that the viscosity remains correct even if there is change in the temperature in the fluid. So the measure of viscosity index should be very high even with respect to as now compared with respect to the correct viscosity parameter that we have defined. Moving on with the demulcibility, ability of the oil to separate water from it and to resist emulsification. See, when the fluid is being considered to run over a period of time, there may be any chances of leakages that may happen in the entire hydraulic system, and that particular leakage may result in the influence of the moisture content to enter inside the hydraulic system. That may result in accumulation of moisture content or mixing up of moisture content along with the oil. That results in again increase in the friction between the components and reduces the life of components or moving components in the hydraulic system. So at that particular point of time, this demulcibility property is being considered, wherein the fluid, whatever we take or whatever we suggest for a particular application, should possess a high ability of separating the moisture content or water from it during its working cycle. Moving on with the oxidation stability. So this is defined as the ability of a fluid to resist oxidation. Again, in contemporary with the demulsification factor here, if the leakage that results in the hydraulic system, if there is additional accumulation of air particles to come and enter into the fluid may form foam, or it may result in the formation of gum-like element once that particular structure is being formed, and that directly results in the effect on the viscosity parameter of the fluid, that again reduces the shelf life of components in the hydraulic system. Hence, the fluid which is to be selected should possess high oxidation stability. Moving on with the fifth parameter, lubricity. It is the ability of a fluid to lubricate moving parts effectively to minimize the friction. So this is one of the major selection parameter for any kind of hydraulic fluid. And the last one is rust prevention. As we all know, rust is a formation of iron oxide. So here, with the addition of certain additives, the hydraulic oil, which is being considered as a fluid working medium in the hydraulic system, should resist the formation of rust over the moving parts, and thus it should increase the shelf life of all the components in the hydraulic system. Thank you.